All right. I'm in my office today. Figured change the view a little bit. So in previous videos, we talked about decisions based upon a random event. That random event could be rolling a die, flipping a coin, whatever. Now let's build even upon that. Not so much the randomness, but say we have a situation that we're looking at something and we're analyzing something, and then we're breaking it down into smaller and smaller manageable parts. For example, let's say I give you a big box of pennies and I tell you to count those pennies. Well, we're going to take different approaches. Maybe we stack them up in tens, maybe we stack them up in 20s, but we've been organizing things like that forever. We learned to do that as a kid. Maybe we wrap them or something like that. So we're going to do a program that's going to take some of the knowledge that we acquired in previous sections and apply that with our decision making process. So we're going to use, some people, when do you ever use modulo or floor division? Well, you do that all the time. Again, sorting pennies or sorting change is probably a very common one. Putting people at tables, you have a party and five people or six people to a table, and how many tables. So let's do a little bit of a program. So let's go up to my screen, and we're going to go into the Python interpreter real quickly and just a real rehash of modulo or floor division. If I have a number and I divide it by a floor division by another number, that's going to give me what? That's going to give me the all the times that 3 can go into 5 wholly, and right now it's only 1. If I wanted to find the remainder, right? So 3 goes into 5 one time with a remainder of 2. Now, again, some of you may be saying, I'm never going to use this. Why? Well, you will use this. You have been using this your entire life. You just don't realize it. So now you have to train yourself, which means then you have to train the computer. Now, I'm going to use a different IDE today. One of the videos I was using Zybooks. Flip the coin. I'm going to use Replit, the online IDE that I tend to recommend new students because there's nothing you have to install in your program, and it gives you a little more flexibility than the Zybooks one. The Zybooks is good, but let's do Replit. All right, so I'm going to go up to my Replit, and there's nothing there. And like I've told you before, I do cheat a little bit. I do have my code on one thing and predefined code, and I'm gonna put it over here. Let's do a program where I give you a bunch of pennies, or I give you just a big number, and I said break that number up into the number of thousands associated with it, the number of hundreds, the number of tens, and the number of ones. So let's say hypothetically I give you the number 5,643. You say, well, there's 5,000s, 600s, and four tens, and 3 left over. It'll make more sense as we go through it. So the first thing I want to do inside this program is I want to just gather that information. I want it on the screen. So through the magic of cut and paste, save a little time. Should be saving time. I'm going to have my input statement. Okay, input a number. I'm going to tell the user what is your number. The number has to be less than 9,999 and still greater than 0. So basically, up to a 4-digit number, except a 1-digit, 2-digit, 3-digit, up to a 4-digit number. That's all that little thing is saying. This is a comment that's going to apply to the screen. If I was to run this program now, it would just say, what's your number? And then we kind of think. So I know I'm going to be collecting the number of thousands, the number of hundreds, and the number of tens, and even the number of ones. So let me put a value there. And I'm going to say, just to kind of, right now it's set to 0. Hundreds is going to set it to 0, and tens. All right. I'm just going to assign them zeros, so just in case there might be something residual in there, in the memory, but just one of my practices. Now, we're going to do an if statement. The first thing we want to determine is generally where does that number fall into? Is it a 4-digit number, 3-digit number, and we're going to work from the top down. So we're going to tell the computer to ask us if and we're going to say if the number is greater than or equal to 1,000, right? So we're looking for a 4-digit number. And if number is less than or equal to 9,999. Now we're going to stop here. What I just did could potentially cause issues, especially when our conditions get a little bit more complex. So I might want to clean this up a little bit so it makes a little bit more sense both to me and affords me the ability maybe in the future if it gets a little, I can fix it a little bit better. So I'm going to just use our old friend parentheses. All right. I'm even going to clean it up more. I'm going to encase the whole thing in parentheses. All right. So the whole condition has to be met for this to be true. The number has to be greater than or equal to 1,000 and less than 9,999. So this is going to be testing for a 4-digit number. And as I mentioned before with Python relies upon indentations. All right. So anything that is indented underneath this is where it's going to fall in, or what's going to be executed. And I'm going to put a little comment here. I'm going to say find the thousands digit. All right, just a little comment so I can work on it. How do we do that? Well, we do floor division. Right. So here we would say 1,000 or thousands is going to be equal to number floor division 1,000. So basically, if there is a value in the 1,000 thing, put that into thousands, right? And then print that out. And because thousands is a integer, I have to typecast it and spell it right. Square everything off. All right, so we now have, if it falls in this range, we're going to be able to put the number of thousands into my integer variable called thousands, right? Now, we basically have to subtract that number from the bigger number. Remember, imagine that we have a bunch of pennies there, and the first thing we're going to do is we're just going to block out the number of pennies or whatever. So we basically have to subtract the number of thousands out of our original number. So basically, we have to remove, again, that's just a comment there, the 1,000, spell it right, Nick, the 1,000 from the number. And we do that with that Modelo division. So here, we're going to say number, we're going to reassign number, is going to be equal to number, reassigning itself, Modelo division, but this time we're going to say the number of thousands times 1,000. Now, if you don't understand what I'm doing right now, pause the video and look at the screen for a while. All right, I'm not going to pause, but pause the video for it. It's basically saying, okay, let's say we have the number 1982. We find the number of thousands, which would be 1. All right, that's good, and that's determined here. And we would print out thousands, there's 1. And then we need to remove that 1,000 from the original number. So number is now going to be equal to number, number is going to be equal to number, and we do that Modelo division, and we're going to basically replace number with what's ever left over by removing that 1,000. Could I have done it with a different formula? Yes, I chose to use this formula because it just keeps reiterating that that function right there. Now, what happens if I give a 3-digit number? Okay, we're dealing with a 4-digit number. What if I give it a 3-digit number? This is not going to work. And we could run into issues because now we want to tell the system, or we want to tell our program that thousands, there's nothing there. There's a 0 there. So you know what we're going to do? We're going to say else. And here, we're just going to say, thousands is equal to 0. And we're going to print thousands. 0. We don't have to do any typecasting because it's a literal. So this code, I was kind of pointing at the screen there. This code is basically saying if you give me a 4-digit number, I'm going to determine the number of thousands, and then if there is no thousands, then I'm going to do. Let's run this code. Before we go any further, let's run this code. Test it. So we'll say run, and I'll give it the number 1982. It says there's one value of. What if I give it a 3-digit number? I'll run it again. And this time I'll say 982. 0. So now my program, I know that part of my program's logic works. But we want to keep breaking things down over and over until we can't break them down anymore. And our decisions are going to be based upon our previous decisions. And that's really the heart of this video. There's 2 things associated with this video. One is we're using information from previous sections, floor division, modulo operation, and now our decisions aren't based upon some kind of random event, rolling of die, flipping a coin. It's based upon us breaking things down, right? We can do this with pennies. We can do this with any kind of number. Later on, we can do videos where we're breaking down strings, but we're just looking at the numbers. So we need to do this with what? We need to do this with 100s. Now, I've always warned you, be careful about copying and pasting, but this might be a time that, could I copy this and then paste it down? If I'm going to do that, I need to be really careful, right? So I'm going to say copy and paste, but now I have to go through this section. This section is, put a comment here, this section is looking the number, spell it correctly, Nick, the number of 100s. All right, so here we got to change this to 100. This has to be changed to 999. You see the logic there? So now we're looking for 3-digit elements, three-digit numbers, and that's in the range of 100 to 999. We better change this. Have to change this. So maybe this copy and pasting would take too long. Might have been easier if I just typed it out. I did this on purpose. Right. Again, we really want to be careful about copying and pasting because at this point, it may have taken longer to copy the logic from someplace else and make those little tweaks, but now I have to double check everything. Things look fine. Let's run the program here. So here, again, I'll give the number 1982 or 1928. It really doesn't matter. It says there's 1,000 and there's 900s. Well, let me clean that up a little bit. Okay. You can kind of see where this is going. We're consistently following the same logic. Determine the number of hundreds and tens and ones or thousands, and we keep working on this. But our decisions are fundamentally going to be the same. They're just based upon what we're now creating. Now, for brevity's sake, I'm going to copy from my other screen 3. All right, before I run this program, let me double check the logic. Give me a second here. All right, just double checking my logic, cleaning some things up here. All right, let's run this program and let's see what we get. Put in a number, 1982, and we get the value 1,000s, 900s, 8 tens, 2 ones. Let's put in a 3-digit number. Run the program again, And this one will say 765. All right, 0,700. All right, let's do a two-digit number. All right, and finally, let's do a one-digit number. It wasn't so important that we find and break these things down. This was a demonstration of how we build upon previous knowledge, and then we break stuff down, and our decisions are based upon what we broke down. Previous videos, it was random. Now it's not random. It's something we can control. Think about all the decisions you make that aren't so much random. You say, well, if it's raining, raining's not random, but if it's raining, bring an umbrella or something. If the light is red, you stop. If the light is green, you go. Those are all determination-based decisions. You see something, an event or whatever, and you make your decision. All right. So with that being said, hey, let's go out and learn something.